Tuesday of week 1. And we started off talking about the force between two charges, which is K, Q1, Q2, all over R squared, where K is a constant. And it's 9 times 10 to the 9 in SI units. And R is the distance between them. Okay, so we had a setup in a square with 4 charges. And we had a plus Q, capital Q in the upper left-hand corner, lower left, upper right, and then a negative Q down in the bottom, and a center charge of negative Q. And each side of the square was L. So the question was, find the force on this center charge. So we're going to draw a free body diagram of the center charge, and I'll write that down. Find force on center charge. So this is the net force, and so due to the upper left-hand corner, we remember that opposites attract, so there's one force going this way. Due to the lower left-hand corner now, opposites attract, so there's a force going this way. Due to the upper right, again, opposites attract, so there's a force going this way. And due to the lower left-hand corner, like charges repel, so there's a force going this way. And the idea here is that because the charges are the same, the forces between any two charges here are just going to be K, Q times Q, all over the distance between them squared. So the force due to each one is K, Q, Q divided by, well, let's see, the distance between the charges, this distance here, I need to figure out what that's going to be. So if I use the Pythagorean theorem to find the distance between them, so I'm going to take this distance, I'll just call question mark squared, so question mark squared is equal to L over 2 squared plus L over 2 squared. So between any two charges, I have L over 2 and L over 2 to find the distance between them. So this is going to be the same thing as L squared 2 times L squared over 4, which is L squared over 2. And so that means I'll rewrite this as the force due to each is K, Q, Q, all over L squared over 2. And I'll simplify here. Okay, and so I noticed that the two forces due to the lower left and upper right will actually cancel when I add them together, because if I choose, say, axes that look like this, the x components will cancel. So all I'm left with is 2 of the y components. And so the net force is just equal to 2 times 2k q squared over L squared, which is 4k q squared over L squared towards the upper left. And that's the answer.